Project Eagle. The challenge is to design and build the largest and most technologically and environmentally advanced cruise ship in history. I'm Roland Smith. This is the story of creating what has never been done before. It is taking an idea to implementation. It is a cruise ship so immense, there is none other like it in the world. In this, the first of our three-part series, you'll see why and how it started out as just another modern cruise ship, grew in concept and in reality to be far larger than any cruise ship ever built. In the 2 years it will take to build the first Eagle-class ship, the Voyager of the seas, designers and engineers will face serious challenges turning the tiny idea into the immensity of a ship. The shipyard will have to construct a cruise ship substantially larger and more complex than any other in history. And at the offices of the owner, Royal Caribbean International, everyone involved will be pushed to their limit as they oversee building not only the first 3 Eagle-class ships, but simultaneously embark on design and construction of 5 more large ships in other shipyards. Construction can be a dangerous time, especially aboard a ship. We'll see how workers deal with day-to-day problems, and we'll go behind the scenes to see how the complexity and enormity of the project will stretch the resources of the yard and the cruise line in a race to build and outfit the ship in just 2 years. A destructive onboard fire during construction will set the project a month behind schedule. The project will grow well beyond initial ideas, expanding in size, complexity, and cost. Our cameras will take you on a momentous journey into the many stories behind the scenes, and it begins 2 years earlier in the minds of men and women with vision.
We knew for quite some time that what we wanted to do was offer a different type of product that offered more variety, more choice, more selection.
There are very few industries that have such potential growth as the cruise industry does. Our competition is Vegas. Our competition is Hawaii. It's definitely Disney, Orlando. And that's what we're looking to do, is to give the people today who go to the resorts of the world an opportunity to spend their resort time at sea.
When you design a ship, it's not like building a house where you say, I want 6,000 square feet or 7,000 square feet, and you know what that means. When we started, we knew we were going to be building a ship that was bigger than the, in effect, then standard, which was sort of in the 75,000 ton range. I think I would have guessed at the beginning it would have been in the 110,000 ton range. But when you started adding all the new things that we added, and in particular Studio B took up a great deal of space, we wanted the dining room experience to be spectacular, and when we added all those things together, we ended up with a bigger ship than we originally intended.
Cruise ships over the past 20 years have gotten bigger and bigger. There are several reasons why.
Like no vacation on Earth. We don't say like no cruise on Earth, it's like no vacation on Earth. We're positioning our vacation experience as a viable vacation option, not as a cruise experience, but a viable vacation, relevant vacation option to anything you can do on land. You can do on our ships and really experience the vacation of a lifetime.
And we have to give them these options, and all of our research has shown us that, and the Eagle will display the result of a lot of that.
In a quest to add many new activities and accommodate a larger passenger load, the ships keep growing and growing.
Is bigger better? And why? One, is it? Is it better? And if so, why?
Actually, from a cost side, the bigger it is, the more cost-effective it is. It's where you get into the smaller vessels that you lose that efficiency.
What we're building is going to be so much more spectacular than our competition. All our competition did was go out and take one of their existing ships and made it bigger. We're basically going at it from a whole new concept and design, and basically we've taken a greenfield approach and we're making it different.
Say to someone, this is the largest passenger cruise ship ever built, and that statement inevitably invites comments and comparisons to the Titanic. The fact is, the Titanic was the largest of its era, All other comparisons really don't fit. Ship sizes are measured in gross tonnage, and that in turn is based on the volume of the ship. The Titanic, for instance, was 46,329 gross tons. Huge for her day. But the technology and materials to build bigger and more sound vessels would advance rapidly. The QE2, 70,327 tons. The Queen Mary, 81,237 gross tons. The U.S. Navy's biggest aircraft carriers, the Nimitz class, are an enormous 100,000 gross tons each. The largest ship afloat as of the year 2000 is actually a supertanker, the Jare Viking, that comes in at an incredible 260,851 gross tons. Before Voyager of the Seas, Princess Cruises' Grand Princess was the largest cruise ship at 114,000 tons. The Voyager of the Seas at 137,300 gross tons, 214 feet high and 1,020 feet long, is by far the largest cruise ship ever built. In fact, if you stood an Eagle ship on end, it would be nearly the same height as the Empire State Building. The initial reaction to the idea of a ship this size by some people is not positive. Many express concern over being part of a large crowd on their vacation.
Well, we took size and used it to the advantage of what we think is going to be a phenomenal customer experience. This is a ship where you don't want to apologize for the size, because unless you built it this big, you can never give the experience that we're going to deliver today.
Developing the initial ideas into a workable plan and actually building the ship will be a daunting task. But long before any serious work on the new ship could be considered, the financing had to be arranged.
When we were building the Sovereign of the Seas, the financing of it was a critical path from day one. Arranging for the financing with the lenders and everything else. And that actually was a big distraction from the process of designing the ship, because it took a lot of time and a lot of focus. And so you spent as much time figuring out how you were going to finance it as you did how you were going to build it. For the Eagle, we had now expanded, we had moved into our mega brand strategy, we had developed the company, and we had gone through a series of financial maneuvers so that we had in place the financing that we needed. We had gone public, we had provided equity, we had provided debt financing, we had the capital markets available to us. And so our liquidity when we entered into the contract for the Eagle project was not $15 million, but $1 billion. I will admit that if you are the person that has to sign a contract for $1 billion and $4 million, that is a scary event in any person's lifetime.
Detailed planning is started 3 years before construction. Mr. Fain turned to a highly experienced manager for the project, Harri Kalavara, a naval architect and a native of Finland. Kalavara has supervised passenger shipbuilding at all the major European yards.
Naval architecture, shipbuilding is art, it's not science. That's why it's so fascinating to my mind. This is about project number 39, which I have been the responsible, let's say, project manager from the plain paper onto the finish.
Kalavara and his staff retain noted Norwegian ship designer and architect Njål Ide. Ide's job is a big one: develop the initial concept into a ship design that works functionally and aesthetically.
I've been working since 1981, starting with Song of America, and all their ships after that, I would say probably rather central in the planning position together with the owners. I'm being called the circle man, and I've been called the Asian man, but it's got to do with shapes and volume. And I've been lucky to be able to work with volume, because without the volume you can actually not create anything. But you have to be very responsible to, in some way, form the volume. And that's what the target is, the balance between everything. So hopefully one have succeeded a bit. And even Richard Fain sent me a ruler once and said, couldn't you please do a bit more of this? But then he sent to some of the other architects a compass and said, couldn't you do more of this? Karl Levander is a very skilled and experienced naval architect. I have known him probably for about 20 years. He's actually I think the first one in the market that really started analyzing what cruise was back, I'll call it after the 1970s or something, but he was fantastic.
We do the layout of the vessel. We need to check the strength of the vessel, so but not in a way so that you have it dimensioned, but so that we know that it's feasible to build it. And the most important
Although Kai Levander is with the Kværner-Møse Yard's design group, he is retained as a consultant even before any decision is made as to which yard will build the ships. Kværner-Møse, which has large shipyards in Helsinki and Turku, eventually wins the contract. They are one of only 2 shipyards with the cruise ship experience and dry docks large enough to build the Eagle-class ships. Designing any ship is a complex task, but when it grows to this size, even the engineers and managers have to stop and take a deep breath.
What I felt was the biggest challenge was the volume of the ship. Not the volume as such, but the thing that if you deal with a ship which is half size, you have only the half amount of everything. And when the volume is growing and the number of things is growing, it tends to grow in a way which is not double, it may be 4 times or 8 times.
Now all of a sudden, a ship that size twice as large with many more options, we were trying to apply the same principles for the Eagle ship to start off with, which didn't work. And so we had to have a paradigm change and then start from scratch and say, well, let's forget everything we know.
It doesn't follow a sort of a slope. It's just another one, it's a little bigger. This is a step, quite a big step.
One of the major challenges is the control of the ships. The ports and the fairways are exactly the same dimensions as they are for the existing ships, and when the ship size is increasing, so clearly the margins are decreasing.
Royal Caribbean's chairman Richard Fain was no stranger to building ships. His very direct involvement will be seen throughout the design phase and right through the building process.
Richard's the real visionary behind these ships. He sees things that other people don't see, and he has a real incredible feel for design and dimension. And I mean, we'll be focused on a room in this design process, and we'll be looking at a floor layout, and I'll be looking to see, you know, is there enough space here to pass between the bar and this table over here? And Richard's looking at the same thing, but he's also connecting with an air conditioning duct 4 levels up that's over in this corner, okay, that if he could just get this piece of refrigeration moved over here, we could pick up a whole new table, and then you could move the air conditioning duct down 1 level and reroute it back this way, and he just picked up 200 square feet. Only Richard sees that. And I sit there and go, my God, you know, he's not even seeing the same ship that I'm seeing.
Richard is also a person who knows exactly what he wants, and of course in the process, as he is as involved as he is in the process, so of course a number of things which in the design of the vessels which you can directly say that this is as it is because he has wanted it to be in that way.
What we started out saying is we want these kinds of facilities. And actually, a big question is just how do you handle the logistics on board? You want to make it easy for the passenger to get around and find his or her way around the ship. You want to make it easy for their luggage to get to where it's supposed to be quickly and efficiently. You have to make sure that you have efficient ways for the garbage to go the other direction so that you can handle it easily, and if you handle it easily, it'll be done better. That the amount of creativity grows commensurately.
By the time it's all done, there will be 28 architectural firms and over 3,800 designers and architects working on various parts of the ship.
Pretty much what y'all were showing.
A steering committee is given the task of resolving the many conflicts of opinion and direction, which are the natural result of so many creative talents working on one project.
It's not the most efficient way to do things, but I think it is one of the most innovative and one of the most creativity-generating ways I can think of. Because we get everybody together, we get competing architects together in a room, watch each other present, and actually make constructive suggestions. Other questions or comments?
The major public areas of the ship are now defined, and a general layout is made. Every area is assigned a sponsor from Royal Caribbean.
I'm the project sponsor for my areas, which is the casino. We actually have 2 casinos on Project Eagle. The gift shops, the photo gallery, the beauty salon, beauty spa operation, also the gym, which is going to be the largest afloat.
This is going to be a magnificent dining room. Even it's one dining room, it has this huge opening in the middle, these balconies where you can look down and see what's going on underneath, and it'll be very spectacular.
If you drive around Europe, you see everywhere signs that say, this way to the center of town. If you knew where you were relative to the center of town, you knew where everything was. We wanted to take that concept one step further with the Eagle design. And that's really where we had the idea of almost a central city core that was bigger, broader, and that's really how the design built up.
We also have another performance space that we're calling Studio B now, that is like a television studio, but it's also an arena, it's also an ice rink. It's a very highly interactive, fun space. It's a brand new space for us, and for the industry, one of the first of its kind.
We wanted a very extravagant outdoor sports activity with a full basketball court and rock climbing and golf and volleyball and rollerblading and golf simulators and all the things that you could want to have. And one of the component parts of that was going to be an enclosed and air-conditioned basketball court. And we decided that we would prefer that to be open. And that was one of those issues in which there was fairly strong feelings on both sides.
People sometimes lose track of where they are, particularly as big as a ship is. They forget that this really is a ship. Well, why don't you have a bowling alley? Why don't you have pool tables? Well, basically, we do have a miniature golf course, and the ball does go like this if the ship rolls. But in golf, you can say the rub of the green. But usually in bowling, you don't expect the ball to go in the gutter, at least go in the gutter on its own. And usually, it's driven there by you. So it is kind of funny the things that people do ask to have on a ship.
Throughout 1996 and 97, as designers and architects plan the details of each space, structural engineers and marine architects are busy finalizing the main ship structures and steel fabrication plans. At one point, it is decided to raise the height of Deck 6 by 1 foot, a significant change. We talked about it with the yard's design engineer.
They wanted to have more headroom for the public rooms. We had to make some calculations for the weight also and the stability, for the stability of the ship.
If you raise it 1 foot, can that really affect the stability that much?
Yes. Big effect on the stability.
Areas like the stern design are so complicated that specialists are brought in to engineer the critical structures.
The basic design is done. We're putting in specific parts and stiffeners and plate sizes and working out any problems that may have occurred during the preliminary design. There's still a lot of design work that needs to be ironed out.
An ongoing problem for the yard will be standardizing all the work done by many different design and engineering groups, many from different countries. And of course, like any big construction project, there will be changes.
The ship is constantly changing, so we're constantly having to continually change the design. It's like a domino effect. So if a deck changes, that changes all your measurements to the next deck and so on.
The CAD drawings from Robert, Dwayne, and many other engineers are finalized, checked, then downloaded digitally to a person called a nester.
A nester is a nest of parts. Actually what that is you take a plate and you put all these different parts that we've created in modeling, and you put them on a plate, a particular thickness of a plate, and a machine out in the yard burns those parts that we've created. And so exactly what we do here in the computer, a machine cuts it out there. We do it wrong, it gets made wrong. We do it right, it gets made right.
From ideas to sketches, then artist renderings, it's still hard to imagine just exactly what an area is going to look like full size. How will it look and feel? As a way to test the size and scale, models are built for all the major public spaces.
This is the jazz club at night with the stage here. And then the other areas in here, there's a cocktail lounge here and a card room. And there's a dividing wall here which can be taken away, and this whole thing can be a cocktail lounge. And the reason that's good is because upstairs in the funnel here is the chapel for the ship. And there will be weddings in this chapel on the dayland location. And so people will get married here, come down the stairs and hold their reception. This is the two-story central space of the nightclub. This is a way of studying how we're developing this space, because being a nightclub, it depends very much on lighting. And we were asked to do a high-tech theme for this space. And I think this space actually has complete state-of-the-art lighting and sound. Everybody on this project has been very concerned about the acoustics. And a nightclub functions till 4 in the morning. So
the sound insulation is a very big part of designing.
So
we have floating floors, we have
and the whole thing
is encapsulated.
Yeah.
And that's also why we came, the concept is that the actual dance floor, where most of the noise is in the central part. So we tried to keep that internal, and then you have the quieter areas around towards all the other areas on the ship.
Actually, it turns out the most difficult thing concerning the noise is to stop sound being transferred through the air conditioning system, because you pad the whole room and then find that noise is seeping out through the ductwork. So that has been a problem. From our point of view, it was not so difficult, but for the yard, I think it has been extremely difficult to divert the air conditioning system so that we have a separate system which is only working for the nightclub and not transmitting sound.
We've really made a big attempt to try to physically hide the technology. One aspect of doing that, as you see, is the video cube, which is behind the screen. In the true space on Eagle, you will have 21 of these video cubes within the space.
The Royal Promenade design is based on an actual street in Milan, Italy. Designing an open space this large on a ship presents some serious challenges structurally.
One of the big issues early on was the width of the Royal Promenade. Structurally, the yard said we would like to keep that at 8 meters. And we decided that it would be significantly better to the ambiance to make it 9 meters. And we made models and we made simulations, and we really wanted to get that extra meter out of it. We also wanted more glass in the cabin walls. And the initial response from the yard and from the outside engineers was you couldn't do that. And I went to Harry Coulavara on that, and I said, Harry, I think 8 meters worries me a little bit. 8 meters is acceptable, but we're not trying to get an acceptable. We want, and that extra meter, and there were various reasons why that meter helped quite a bit in terms of the ambiance. That extra meter is quite important. And he said, well, let's see, if we do this and we do that, then terrace this in, and we add an additional support member here, then I think we can get the 9 meters. And the yard came back and said, well, okay, I think we can do it at 8.5 meters. And Harry and I said, well, you know, but it really ought to be 9 meters, and if you can do 8.5, you've already got off the concept that it has to be exactly in a plane, and you can go to 9. And they came back and they said, well, it can be 8.9 meters. And, you know, it's really 9 meters, but we're not going to count this. And I said, well, no, you know, 9 meters ought to mean 9 meters. And they went back, and sure enough, they made it 9 meters. There were a number of things like that, actually, that Harry really was able to focus on and pound on the table on and really get what was needed.
When we introduced and wanted to go for the horizontal atrium, wanted to be sure that this, from the fire safety point of view, is something which gives an advantage. We all know that is one of the let's say, the worst accidents what can happen on a ship. With the atrium solution, we have created a shape which is, let's say, safer in case a fire will burst.
The promenade spans 3 fire zones, which means giant fire doors must be built to isolate each zone to contain any fire in the area. Designing fire doors for a 4-story high open space on a ship has never been done. It was relatively easy for the engineers to create it on paper, but it would take much more than a computer model to convince the Certification Society and U.S. Coast Guard that they would actually work. Mock-ups and numerous tests would be required. Even as late as sea trials, the big fire doors would remain a major inspection item, since they must work in a rolling sea and must close relatively quickly. The Eagle ships have a new engine room design. Even if there were to be an engine room fire, a worst-case scenario, safety and reliability are part of the design criteria.
On the safety side, so one of I think most crucial element what we have done here is on the machinery side, where the ship has been built with 2 totally independent machinery rooms, engine spaces. We have 6 main engines which generate the electric power what is needed for the ship's, let's say, different services and also for the propulsion. And these are divided into 2 rooms which are totally independent, which doesn't have anything in common, where they have totally independent. If something knocks out one room, so we will have 50% of the power available in order to let's say, to run the ship and provide the services.
With 6 engines and 6 generators, it is possible to run the entire ship with several engines shut down for maintenance and still have a backup. The entire engine room is really like a city power plant, since virtually the entire ship runs on electricity. Total power output is about the same as a small city.
Yeah, we have 6 diesels, which are producing 12.6 megawatt of electricity produced in generators, 1 generator for each diesel. If everything are run 100%, you produce 75.6 megawatt of electricity.
Architects translate ideas into concepts, drawings, then into models and mock-ups. Nowhere is this as important as when it comes to cabins. Nestled among the gently rolling hills of Finland, just 20 kilometers from the yard in Turku, is the Pakia Cabin Factory. The cabins are built as individual units, with electrical wiring, plumbing, cabinetry, all complete. They will be tucked into the ship, welded into place and connected to the ship's systems. All that will need to be added is flooring and furniture. All the cabins except the largest suites will be built at this factory. The suites are custom built aboard the ship. It is April 14th, 1998, and the factory has built many scale models and test rooms for hallways and cabins. Hundreds of combinations of colors, textures, mirrors, fixtures, and furniture will be designed, built, and tested full size before any production line is started.
Pastel colors, really, because these cabins are small and they want to get them as airy and open as possible, and that the effect of being in the cabins is pleasant, very comfortable.
Actually, the purpose of the mock-up is to get decisions made in time.
that we can start the process. Have to face the fact that decisions have to be made earlier. Of course, sometimes it would be nice to delay it and like this, but actually it doesn't help too much. Sooner or later the problems, they come. Why don't face them in the beginning?
Facing the problems of design and getting approvals in time to build some 2,000 cabins for passengers and crew is a task that takes architects and executives back to this mock-up many, many times.
Totally, we have about 2,200 cabins, and if we make, for example, 10 kilos mistake per cabin, you can easily calculate how much it means. Each kilo is 2.2 tons, so that's why it's very important. So it's a very good control for the weight, for example, which is essential for the yacht.
There are so many more pieces of this puzzle needed to support this city afloat. There has to be a hospital, a jail, which in this case will be made of 2 cells, both padded. The laundry room facility will need to clean 5,000 crew uniforms, about 12,000 sheets and towels every day, and that doesn't include any passenger laundry or dry cleaning. Of course, there has to be some very large storage areas for everything from food to cleaning supplies, spare parts for all the air conditioning and other mechanical systems, hundreds of gallons of paint, even huge rolls of carpet will be stored. There are spaces for repair facilities, including full wood and metal shops.
And in order to make you understand,
typical of the thousands of problems involving space allocation is where to put the cherry picker maintenance vehicle, which is needed in the 4-story tall Royal Promenade.
the solution we have settled with is this one. It's only got one drawback. It's a marvelous machine, and it needed a garage. But believe me, the yard was very kind to us because they gave us this. All of a sudden they said, we have some empty space here. Is electrical equipment, do you want it for something? And I just dropped down and said, hey, this is the garage. Finally brought this.
This is the SOLAS Book of Regulations, as determined by the International Maritime Organization. SOLAS stands for Safety of Lives at Sea. In order for a passenger ship to receive an operating safety certificate, it must comply with hundreds and hundreds of regulations.
In terms of the safety aspects, of course, we work with all kinds of different authorities, from the authorities of the flag state where the flag of this vessel will be, to the United States Coast Guard, to Norwegian Veritas, and you can get a whole long list of all the authorities that are involved in approving the vessel in terms of the safety in the fire zones and the watertight zones and all that.
A classification society, well, it's a somewhat strange animal. It's an old institution. Our institution is 133 years old. We were founded in 1864. The objective is to safeguard life, property and the environment.
The inspectors from Det Norske Veritas, based in Oslo, Norway, will review and must approve every aspect of the design, construction and testing of the ship. Without their final approval, the ship cannot be insured, cannot be certified, nor put into service.
And we work quite closely with the US Coast Guard. We are authorized by them to review passenger ships abroad prior to coming to the US. And we work together with the US Coast Guard to interpret their regulations, the CFRs, and to see to that the ship also complies with what the Coast Guard expected to.
The stability of a ship is critical to safety and to comfort. To be certified, the Eagle-class ships have to be able to recover from a roll of as much as 49.5 degrees. The maximum roll for passenger comfort is set at just 5 degrees, and the ships have to be able to withstand a beating by huge waves and remain stable with structural integrity. The huge open spaces on the Eagle-class ships, and in fact on all big cruise ships, which are multiple stories high, must be strong and rigid enough to withstand the movement and stresses of a ship at sea. And yet, like a large airplane, the ship must have some give. It must bend and twist with the huge stresses it will encounter at sea. It is a serious structural engineering challenge.
What had developed was the advent of the use of supercomputers in calculating the stresses on a cruise ship. So with the ability to calculate these stresses and in effect to buttress the side of the vessel, you could now consider building these large atriums.
The structural design concerns itself with strength first, but with a cruise ship, that's only the beginning. With only 28 feet underwater and 214 feet above, it's only natural to wonder how the ship will keep from tipping over.
Everything above the sun deck is of aluminium. We wanted to maximize the free heights and have more free heights on the public decks than what is, let's say, normal. And in order to get the margin for that, so we wanted that the top construction is as light as possible, and that's why we have done it of aluminium.
Using aluminum for the topmost structures solves the problem of too much weight on top, but that will mean finding a way to bond aluminum and steel, two metals which do not weld together because of their atomic structure. One more problem to solve. Stability comes from both weight distribution and hull design. Clearly, the heaviest parts of the ship are on the bottom. The diesels and generators, the electric transformers, the fuel, water, and all the heavy equipment, all are at the lowest levels. In the forward part of the 'tween deck are the first crew cabins and the laundry. The aft areas are open to the engine and generator spaces, while the anchor chain lockers are in the extreme forward area of the ship. Deck 0 has a large number of crew cabins forward and machinery aft. Machinery storerooms and shops are located in the aft areas of this deck. Deck 1 has a large number of crew cabins as well as the main service corridor for the ship. This is where the baggage will be loaded and all main service items flow. The ice rink, a very heavy area, is on Deck 3, still low and in the center of the ship. The ice alone will weigh 8 tons, and the retracting floor will add another 5 tons. The hull of the ship this size is an amazingly complex design. First of all, it has to have structural integrity, but there is much more to it than that.
We have been able to reduce the propeller-induced vibrations and also the noise levels almost to 1/10 of what would be normal for this kind of ship.
If let's say this is the part of the ship hull here, and when we mount this bodied Azipod system, we can have the propeller here, and you can see it immediately now. That is opposite to normal. In conventional ship, you have the propeller directing to the stern, but we have it here in this Azipod units. It's like a pulling drive. And one big advantage is that when the ship moves through the water, that gets the water flow very evenly. The propeller is not disturbed.
The water flows cleanly into the propeller. You get a beautiful wake field, no turbulence. The propeller will be very easy to design. It will be easy to optimize it, and you get less noise, you get less vibration. With the Azipod, you can actually turn the propeller in any position, and you can get full power also going sideways.
There are 3 propulsion pods on the Eagle ships, 2 face forward and 1 aft. The 2 on the outside are called azipods and rotate 360 degrees, steering the ship and eliminating the need for rudders. The center pod does not move, and it's called a fixopod. Although it looks like there are rudders behind the outside pods, they are actually vertical stabilizers and do not move. They were not part of the original design. The supercomputers are amazing in predicting stability, but with the safety of the ship at stake and a new hull design, extensive model tank testing will be done before any steel is cut. These exact scale models of the hull are used to test each design. One of the fascinating engineering feats is how they design the hull so the ship can move through a harbor and not put out a huge wake, which would damage boats and piers. The big bulbous bow on ships are there to start a wave of a certain form. As the wave passes down the side, a second wave is created 180 degrees out of phase with the first. When they meet, they simply cancel each other out. Without this design, the ship would put out a very destructive wake in harbors or wherever she sailed. On the Eagle-class ships, the hull is so large, this phenomenon will actually occur twice. In these early Azipod tests, flow past the propellers is checked. Notice there is nothing behind the outside pods on the hull. The fin that looks sort of like a rudder in the middle is actually a stabilizer, like the tail on an airplane, and it does not move. These models simulate exactly the weight and stability of the real ship. This is the first turning test to see how far the ship will lean in a high-speed turn. The test reveals what engineers consider a serious problem. The ship rolls far more than the designers had hoped. In a roll that steep, even though the ship won't be anywhere near capsizing, passengers and crew would probably fall down and anything not bolted down might slide around dangerously. The hull designers need to go back to work. The twin vertical stabilizers are added to the models and put to the test. In this split screen, the original and new designs are compared to look at the difference in these steep turns. The final test will come during sea trials, when hard turns at full speed are tested with the real ship. Here in the 3-story high theater, the show producers and theater architects are determined to make sure no pillars block any view. For the marine architects, it presents a formidable engineering challenge, which becomes a serious point of contention between the two groups. After many long meetings and hundreds of structural studies, the engineers find ways to eliminate most pillars by strengthening all the main girders and adding additional cross members. But in the end, a few pillars must remain. This is just one of thousands of compromises between artists, architects, and engineers.
We're creating art for a ship, yes, where people are supposed to like what they see. I mean, it has to be very decorative. You can't take a very avant-garde painting and put on the ship because nobody would like to look at it. I mean, we have to face that a lot of the stuff that you see in modern museums, you could never, ever use on a cruise ship.
RCI was one of the new patrons of the arts because there isn't anybody spending that huge quantity of money on new, very good quality, and in some case very highbrow artists.
Planning, commissioning artists, and coordinating the creation of what will be 56 tons of original art is a huge task. And as you can imagine, there are many discussions not only about creativity, but about the budget, which will go as high as $13 million and end up at $11 million.
The yard is saying they don't want to do it and it's going to be more money, and RCCL is saying we've already paid for it, so you are going to produce it. So there's a little argument going on.
These are the last things to go up. Why do they have to be done like 7 months in advance?
Because it takes 7 months to produce them.
But it can't do. That's not. Little job.
This
is them covering themselves.
This has been requested by Grabowski and approved of by John Lazell. This is done. This was done months ago. Let's get it over with.
Well, yeah, I know, but I'm just thinking you're not going to have all of that. I know how it is. They take sending this such a long time.
Because we can never foresee what is going to happen on the yard. And we can have artists sitting waiting for 3 weeks because one part of the sculpture went to Bali or whatever it went to. And then you have to try to keep that artist calm for maybe up to 3 weeks, which can be very difficult.
The ship's a living environment, a moving environment with a lot of people passing through. So they have to be safe, they have to be passenger friendly. The art pieces have to be passenger friendly. They have to be secure, they don't want to fall off. And all of these things, 99% of the artists are quite aware that their pieces are going to be touched, they're going to be abused in some cases.
If you think of a collection in a museum, certainly there's a certain amount of people that actually go to that museum to see that collection. But if you think about the thousands of passengers that come on board those ships every week that are actually seeing this beautiful collection of art, and some of them are, it's one of those situations, if they wanted to start taking off some pieces and putting it into a museum, they would have a serious art collection.
Some of the ports of the Caribbean can handle the new big ship, some cannot. Planning must include moving the passengers quickly to shore and back again, plus provisioning and care for the environment.
We know exactly what it takes to feed X number of people on this size of vessel, and we look at the menu mix at the same time. We have flow charts that we develop which are conducive to the way that the menu is running, and it is from that that we're able to determine how much beef and ham and pork and bread, is flour and sugar and everything else that is necessary to be able to put on board a vessel.
We have to prepare for this size of ship 23,000 meals a day. I got 212 people working in the galley. We have baker, pastry, pantry, which is a cold kitchen. We have vegetable, fish, roast, soup.
If you're serving, let's say, 3,000 plus guests when the ship comes out, you can't very well have frozen product that you just pull out the thaw that day. So our food operations actually plans about 3 days in advance. So they have a schedule of when different items come out of either frozen storage and goes into thawing areas, so that they can have all of the prior preparations done before the guests even come on board.
Everything I get is in Miami. Like I have 7 days consumption, 10% extra. Whatever I order is for 7 days, and I pick up only in Miami. Nothing is to be bought in any island.
Feeding and housing 4,600 people for 7 days generates a lot of garbage and waste. Before the late 80s and the early 90s, the shipping industry was less than consistent in being environmentally responsible. Lax enforcement of regulations led to the dumping of garbage, solid waste, and oily bilge water at sea. A significant effort toward building environmentally friendlier ships started in the early 90s. Regulations and enforcement increased. The attitude of ship owners and senior managers of cruise ship lines today reflect the shift in attitudes toward the environment.
You know, we do make our living actually from these oceans, and so it's important to us to protect them.
Well, we are far above and beyond any environmental regulations, national, local, IMO, MARPOL and things like that. Yeah. On Royal Caribbean, we are following the green ship concept, which is zero discharge overboard. That's it. No cigarette butt, no toothpick, no chewing gum, nothing is allowed to be thrown overboard. So we are promoting this policy as well to our passengers, and we are advising them, you know, over the P&A, nothing to be thrown overboard and things like that.
For the Eagle ships, RCI management demands the design to exceed current environmental regulations in every area. Between the onboard treatment plants and holding tanks, this should be the most environmentally friendly cruise ship ever built, despite its size. Newly designed oil-water separators are a critical part of the planning, as well as more space for holding, compacting, and incinerating waste. Final system design and testing will be needed to see how well the environmental engineers have done their job. The critical designs are done. The huge dry dock holds another ship, soon to be launched, making way for the first Eagle ship, Voyager of the Seas. With steel on its way from the mills to begin the building process, the pressure to finalize plans for each area grows, a process which will continue long after construction has started. From this point on, the team has 104 weeks before the first paying passengers will board the ship on November 21st, 1999. Before that, many thousands of decisions must be made, problems solved, And although they don't know it yet, there will be serious setbacks, including a devastating construction fire which will push schedules and people to their limits. It will eventually take 10 million working hours by men and women in more than 15 countries to complete the design, to build, to test, and deliver the largest cruise ship to ever float, the first of the Eagle class, Voyager of the Seas. 3 years of work, and this is still just the beginning. In the second episode of our story, you'll see how the ship is built, floated, and tested. You will see how the Finnish yardworkers cope with the severe cold of the Arctic winter. You will be aboard for sea trials, where every system is pushed to the max, as the Voyager of the Seas leaves sheltered waters for her first venture onto the open sea. I'm Roland Smith.